Well, hello guys, this is the fifth video on trigonometry. As I told you that the first three video is for class 9 and the fourth and the fifth, that is the last two video, is for class 10. Okay, so today we'll discuss about the trigonometric identities. Alright, before that, if we'll go through the first video, then we have discussed about some of the reciprocal relation or the trigonometric ratios. Okay, in which we've discussed about sine is a reciprocal of cosec. Okay, cosec is a reciprocal of sine, cos is a reciprocal of sec, sec is a reciprocal of cos, tan is a reciprocal of cot, cot is a reciprocal of tan. Similarly, we have two more formulas for tan and cot, that is tan theta is equals to sine theta by cos theta, and cot theta is equals to cos theta by sine theta. Alright, now what is trigonometric identities? Now, like in algebra, any algebraic equation, alright, for example, if I write x square is equals to y plus 3, so any algebraic equation is called algebraic identities. Similarly, any equation, okay, an equation with a trigonometric ratio of any angle is called trigonometric identities. Alright, so if you look at this one, all of these are equation. Alright, so we can take all of this as trigonometric identities. Alright, but it's divided into two parts. Okay, so we have reciprocal identities. These are called reciprocal identities. Okay, now another one is fundamental identities. Fundamental identities. Okay, so all are identities actually, but these are called reciprocal identities. Alright, now let's discuss about the fundamental identities, which are called the trigonometric identities. Alright, so the first one is sine square theta plus cos square theta is equals to 1. So this is the first trigonometric identities. Now let me explain you with an example. Now if I write sine square 32 plus cos square 32. Now if you go back to video number 2 and 3, we discuss about the complementary angle and the standard angle. Now if you look at this one, is it a standard angle? No, it is not the standard angle. If it is a standard angle like 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, we have the values, but sine 32 we don't have. Alright, actually we have the values, but till class 10 no need to know the values of all the trigonometric angles other than standard angle. Alright, now without doing any calculation, what we can write is if the angles are same, so if theta represents angle, if the angles are same and if we have sine cos with square, then we can directly write the value as 1. For example, sine square a plus cos square a. If you look at this one, angles are same and we have square, then we can directly write it as 1. But if it is sine square 32 plus cos square 31, if you look at this one, square we have, sine cos we have, but if the angles are not same, we cannot use the formula. Okay, if it is sine 32 plus cos 32, now if you look at this one, the angles are same, but we don't have square here, so we cannot use the formula here also. Alright, so the first one is sine square theta plus cos square theta is equals to 1. Now with this formula we can derive another two formulas. For example, if we take sine to that side, we can write it as 1 minus sine square theta. So this means we can convert cos into sine or sine into cos. Similarly, sine square theta, if you take cos to that side, this will be a 1 minus cos square theta. Alright, now number 2, 1 plus tan square theta is equals to sec square theta. Now for all the fundamental identities, not the reciprocal identities or the reciprocal relation, all the fundamental identities, these are called fundamental identities. Alright, so all these fundamental identities includes square. If we have a square, then try to relate whatever term is there with that fundamental identities. Okay, now square, keep this in mind, the square are very important. Tan square theta, now if you take 1 to that side, sec square theta minus 1, or if you take tan to that side, sec square theta, if you take tan to that side, it will be minus tan square theta is equals to 1. Okay, similarly, number 3, 1 plus cos square theta is equals to cosec square theta, or if you take cot to that side, cosec square theta minus cot square theta is equals to 1, or if you take 1 to that side, cosec square theta minus 1 is equals to cot square theta. So this way we can convert sine into cos, or tan into sec, or sec into tan, or cot into cosec, or cosec into cot. Most of the people will get confused with cot, cos and cos. Please go through the formula properly. Alright. Now in this exercise, what we do is you'll get an equation. Okay, then the question will be prove that the equation will be given. For example, the equation will be given like sin a divided by 1 plus cos a, and now prove this as 1 plus cos a divided by sin a. Now this is an equation. The question will be prove that. So what we have to do here? Yes, what we have to do here is we have to reduce this into a simplest form, and whatever value we get, that has to be equal to this one. So left hand side is equals to right hand side. Alright, by using all the trigonometric identities like fundamental identities as well as reciprocal relation. Now one important tip, alright, always try to convert all the trigonometric ratio, all means cosec, sec, tan, cot, into sine and cos. If you convert the values into sine and cos, then it will be easy for you to do the calculation. Alright, so how to use the formula, how to use all the trigonometric ratio. Okay, so we'll discuss that now. Okay, so let's discuss, let's go through some of the examples so that you'll get an idea how to. So please memorize all the trigonometric identities, all the formulas. Okay, so let's try to utilize all the formulas, okay, by taking some of the example. I've already written some of the questions here, so we'll do one by one. Okay, so we'll get an idea how to solve the or how to use all the trigonometric identities while solving the problem. Okay, so now you will get usually from this section, this trigonometric identities, usually you will get a question like this: prove that left hand side is equals to right hand side. So if we go through all the question, what we are doing here is we are proving that left hand side is equals to right hand side. So what we do here is, so let's take the first example. It says sec a plus tan a into 1 minus sin a is equals to cos a. So this is what we are proving. So what we do here is we'll take the left hand side first. Alright, now this is your sec a plus tan a into 1 minus sin a. Now we'll solve this, we'll try to reduce this and whatever value we get at the end, that has to be equal to the right hand side. That is what we are doing, prove that. That means that left hand side, it has to be equal to the right hand side. Now an important note, always try to convert all the trigonometric ratio into sine and cos. Alright, so now sec we can convert it into cos, and tan we can convert it into sine by cos. Okay, this is 1 minus, so sine we'll keep it as it is. Alright, repeating it once again, try to convert all the trigonometric ratio into sine and cos. Alright, okay, now let's take the LCM. So the LCM is cos a, so this is your 1 plus sin a into, now this is already there because here is 1, so 1 minus sin. If you look at this one, 1 sin, and the sin, the terms are same, but only the difference is sign. So can I use this formula, a plus b into a minus b? So what is a plus b, a minus b? It is a square minus b square, isn't it? So we'll use that formula. So this is a square minus b square. Now 1 to 1 is 1, no need to write square. So now, so 1 minus sin. So can I convert this one into cos? Yes. So 1 minus sin square theta is your cos square theta. Right? Now 1 cos and 1 cos will get cancelled. So which is your right hand side. Now one important note, whatever formula we are using here, that we have to mention. That is called statement here. So what are the formulas that we use here? Now since sec a is equals to 1 by cos a, otherwise you won't get marks. then tan A is equals to sine A by cos A. You have to mention this, alright? And then we have used here 1 minus sine square A is equals to cos square A. So, okay, so therefore LHS is equals to RHS, hence proved. Alright, so this statement are very important. Wherever you use the formula on that line, you write the statement. You don't have to write the whole, taking this and that. You just write since whatever formula is it, then okay. So this is how we solve the trigonometric identities. Now let's take another example. So the second question says tan A plus cot A. So let us take the left hand side directly. So this is done. So let's take the left hand side. So tan A plus cot A. Now we have to prove this is equals to sec A into cos. So what we have to do? Yes, we try to convert all the trigonometric ratio into sine and cos. So tan is your sine A by cos A plus cot is your cos A by sine A. Now let's take the LCM. Now the LCM is cos A into sine A. Now sine into sine is your sine square A plus this sine side will get cancelled, cos into cos. Now we know that sine square theta plus cos square theta. Now the angle is AA, so it is 1. So this is your 1 by cos A into sine A. Now 1 by cos is sec, it is a reciprocal, yes sir. And 1 by sine is your cosec A, which is your right hand side. So here also you have to write the statement. 1 by cos is sec and 1 by cosec is 1 by cos is sec and 1 by sine A is your cosec. So this is how we prove. Okay. So the third question says I am directly taking the left hand side cos A into 1 plus sec A. Now after solving this, we have to prove that this is equals to tan A into sine A. Now 1 minus cos A, this is okay, but the sec will convert it into 1 by cos A. Alright. Now here is 1 minus cos A. Now let's take the LCM. Now here we have to write the statement. Since sec A is equals to 1 by cos A, don't forget to write the statement. This is called statement. So this is cos A plus 1. Now, so here is 1. So 1 into cos is cos A. We can write it as 1 minus cos A. And this one, can I rearrange and write 1 plus cos A? Yes, no problem, because both are positive. Now again we use the same technique or the method. So 1, 1, cos, only the difference in plus and minus. So we can write A squared minus B squared divided by cos. Now 1 into 1 is 1. So 1 minus cos square A is equals to sine square, isn't it? Go through the formula. So this is your sine square A by cos square A. Now, can I break this and write sine A into sine A? With the sine square A, we can break it and we can write sine into sine, because sine into sine is sine square A by cos A. Now, sine by cos is your tan, and this is your sine, which is your right hand side. Alright. Now let's move on to the next question. So this is done. So the next question is sine A by 1 plus cos A. 1 plus cos A. Okay. This we have to prove it as 1 minus cos A by sine A. If you look at this one, all are sine and cos. Alright. Now what we do here is we have to use one method here that is called rationalization. And rationalization, what we do is we multiply both numerator and denominator with the same value but different in sign. 1, 1, cos. Alright. Now, alright, so in the question like this and this, we need to rationalize. So here A, B. So A plus B, A minus B is your A square minus B square, and this is your sine A and 1 minus cos A. Alright. Now sine A, now 1 into 1 is 1. This is 1 minus cos A. Now 1 minus cos square A is sine square A, isn't it? You have to write the statement here. Okay, since 1 minus cos square A is equals to sin square A. Now one side and one side will get cancelled, so this is 1 minus cos A divided by sin A, which is your right hand side. So therefore LHS is equals to RHS, hence root. Alright? Okay. Now this is how we solve. Alright? Let's move on to the next one. So it says that root under 1 plus sin A divided by 1 minus sin A. Now see, when you are rationalizing, you can rationalize numerator also, denominator also. It depends upon what is given in the question and what you are finding. So if you look at this one, we don't have the denominator. So what we need to do here is we rationalize the denominator, because denominator we are eliminating. Okay, similarly if numerator is not there, then you can rationalize numerator. But keep this in mind, if you are rationalizing this one, then the sign has to be minus, and if you are rationalizing this, then the sign has to be plus. Alright? Now, so this will be your, now again it will be in that form on the a plus b, a minus b, a square plus b square. Now this will be your a plus b whole square, because 1 plus sin A into 1 plus sin A. So A into A is your A square. Alright? So this will be your 1 plus sin A whole square. Now 1 into 1 is 1, so this is your cos square here. Yes sir. So if you separate the root, alright, then this square will get cancelled. So this is your 1 plus sin A divided by cos A. Now 1 plus cos A, so we can separate, okay. For example, if it is a plus b divided by c, then what we can write is a by c plus b by c, because if you take the LCM, we'll get the same value. Alright, so no problem with this one. Now 1 by cos is your sec a, and sin by cos is your tan a, which is your right hand side. Alright, now let's move on to the next question. Root under 1 plus cos a divided by 1 minus cos A and 1 plus cos A. Now this is what I was talking about. Now what we are proving here is sin A by 1 plus cos A. So if you look at this one, 1 plus cos A, so here the denominator are same. So what we need to do here is we need to rationalize the numerator. Yes. So taking left hand side, rationalizing. So you have to write that one, rationalizing. Alright. Now lysing. Alright. Now we rationalize the numerator, 1 plus cos A and 1 plus cos A. So it depends upon which one you are rationalizing. It depends upon what is given and what you are finding. Okay, in the previous one we rationalized the denominator, but now the denominator is same, so we are rationalizing the numerator. So now this will be your, now same value. If you are multiplying the same value, then this will be a 1 plus cos A whole square. Alright, a plus b, a minus b is your a square minus b square. Now 1 into 1 is 1, so 1 minus cos square. Please write this statement. Okay, so 1 minus cos square. Whenever you use the formula, we have to write the statement. So this is your sin square A, and this is your 1 plus cos A. Now if you separate the root, then this square and root will get cancelled. So we'll get sin A divided by 1 plus cos A, which is your right hand side. So therefore LHS is equals to RHS, hence proof. Alright, let's do the last one. Okay, so it says that cosec, this is number 6, minus sin A into sec A minus cos A into sec square A. This has to be equal to tan theta. So I'm taking left hand side directly. Now remember the rule, try to convert all the trigonometric ratio into sine and cos. So cosec is the reciprocal of sine. Now let's keep it as it is. Now here this is 1 by cos. Don't forget to write this statement. Alright, and sec is 1 by cos square. Alright, so what's the formula that we have used? Since cosec A is equals to 1 by sin A, second we use sec A is equals to 1 by cos A. Okay, if you don't write this statement, no marks. Keep this in mind. Now let's take the LCM. So sine A, so this will be your 1 minus sine square A. Alright. Now here also we'll take the LCM. So LCM is cos A. So this will be a 1 minus cos square A. Now this is your cos square A. Alright. Now 1 minus sine square A is your cos square A by sine A into 1 minus cos square A is your sine square A, isn't it? Just go through the formula, memorize all the formula, and the easiest way to memorize the formula is practice. Utilize these formulas again and again so that that will go inside your brain, okay, and you'll remember it, okay. So cosec square A will get cancelled, one sine and one sine will get cancelled, so we'll get sine A by cos A, which is your tan A. Don't forget to write the statement here, which formula we use, 1 minus sine square A, alright, which is your cos square A, and 1 minus cos square A is your sine square A. And here we have used one formula, since sine A by cos A is equals to tan A. So therefore this is your right answer. Therefore LHS equals to RHS, hence proved. So please go through all the formula and please go through all the examples. Okay, so this will give you an idea to do all the sum. Okay, so if you have any questions, any queries, okay, so please comment there. Okay, if you want, if you couldn't do any sum, or if you want me to do any sum, then please comment there. All right. So in the next video, we'll be discussing about the height and distance. All right. So till